and we've got actually everyone's a doctor. Dr. Thad Szabo. You're a 2012 apocalypse denier?
Yeah, I actually gave a talk as part of a panel on this this past week. So if any of my students are coming in, then they got to see me debunking things earlier this week. So,
so what did they want? What did they need debunked?
So, well, we had a professor from anthropology, a professor from history, and then me from astronomy talking about the various truth about what the Mayans believed and didn't believe, and then me just bringing in there's no alignment, solar flares, hey, we get them every 11 years, so just the usual debunking stuff. See fill plate, right?
See fill plate, yeah. We got a whole series on Universe Today about that actually, and Pamela and I are going to be actually cruising around the Mayan ruins on December 21st, 2012. To celebrate not the end of the world. Well, there's still some tickets left, I think.
I give a final on December 20th, so I can't. Yeah, I have a final. I have to give it December 20th.
Oh, there we go.
That's
all right.
so sad.
Well, that's why there are substitute teachers then.
Oh, don't be that guy.
I won't be that guy.
Every department has that guy.
Or girl. I've been that girl.
I already told them August 21st, 2017, I will not be there. That they know about because of the total eclipse over Oregon. So I will not be there then. So
So if people are kind of sort of have never seen this before, what we do is we hook up a bunch of telescopes live on the internet through the wonder of Google Plus, and we stream the view to you live. Now that's good because it's live, and it gives you a really good idea of what what it's like to be an astronomer. That's bad in that sometimes we get cloudy skies, sometimes we run into technology problems, and sometimes clouds show up or planes fly through the view. So it's definitely sort of the real experience. Now part of this to show you that it's live though is we're happy to take requests and we're happy to answer any questions that you might have about space and astronomy. So all you have to do is you can pose your question in a bunch of places. If you're watching this on the event, which I wasn't able to update, unfortunately, so you're probably not watching this on the event page, but if you are, you can post a question there. If you're watching this on, there's sort of in my stream or, on my page, on Google Plus, you can post a question there. If you're watching this over on YouTube, you can post a question there. And if you're watching this anywhere else, and maybe you prefer Twitter, you could just use the hashtag StarParty, and we'll see that as well. So, so let's get on with what we've got tonight. So first, I'm going to start with what Roy's got, which is that the Veil Nebula?
This is the Veil Nebula.
What is it?
So that's a supernova remnant.
PhD people.
So it's a supernova remnant. So giant massive star gets to the end of its life, one day starts producing iron in its core, and that's it for that star. And as it blows up, it starts expanding through space. A significant fraction of the speed of light, 1/10 the speed of light or faster. And so several thousand years later, you see these kind of streams and wisps of glowing material that's left over from when that thing blew up a couple thousand years ago.
This is the same sort of thing as the Crab Nebula. We're just only looking at a small fraction of it. And it exploded fairly nearby and long enough ago that it's had a chance to really expand itself out so that we can only see small bits of it easily at any given time.
There's like a bunch of different parts to it, right? So you can see the Veil Nebula is one part of it, and then there's a couple of other chunks of it. And it's like a big
Eastern
if
Veil
you think
and
of this
the
part of
Western
it,
Veil.
if you think of this part of it as part of a circle, you can imagine, because it's pretty much laid out in a circle. Is that in hydrogen alpha, Roy?
That's in hydrogen alpha.
Okay.
Is that important?
Yeah, it's cool hydrogen gas, which means this would be a bright red image if we could actually see it colored.
Yeah, I took it originally in this image I took just through a luminance filter, and there's just too much background with such a short exposure, so I switched over to hydrogen alpha and just picked up just that light.
And so will you switch back and forth between those filters depending on what you're seeing?
Yeah.
Okay, cool.
Depending on, right now I've switched all my filters out from the red, green, and blue to my full narrowband set, which is hydrogen alpha, oxygen, and sulfur. So I've been taking tricolor images using those 3 filters.
Nice.
Okay, let's move on to what Stuart's got. Looks like a double star.
Yeah, this is Alberio. And I think we've decided that it's a true double, Thad?
No, actually, as far as I know, the jury's still out on this one, although the orbital period is so large that it's more likely to be a visual double and not a true binary pair.
Yeah, true double is not a phrase, which led to the scrunched up face because it was such an interesting concept. There's double stars, and binaries are a subset of double stars that are orbitally gravitationally linked and separatable into 2 separate stars.
Right, and so, but if the stars are so far apart, then it's hard to be able to detect really if they are just an optical binary or whether they're an actual not a true binary if they're orbiting one another?
Well, so the question is, do we have 2 stars that are simply superimposed on one another on the sky but have gravitationally nothing to do with one another? Or do we have a system that they are gravitationally related but they're separated enough that we don't have time to have seen any discernible motion across the sky? So it can go either way, but this one, they've eliminated it for being a huge period if it is a binary star, and then you start wondering how are those things gravitationally still bound together.
I've seen estimates for an orbital period upward of 50,000 years or more for this thing, so that's tiny, tiny, tiny motions over the time that we've had the ability to measure its spectra.
You've gone a good way around the galaxy in that time, haven't you?
No, tiny. I mean, 220 million years to orbit, so that's yeah, less than a degree.
Pass through an arm.
Yeah, 200. That always amazed me when I heard that number, that it takes us 220 million years to go one orbit around the galaxy.
Mm-hmm.
Like
so we've been around a lot of times, considering we've been around for 5 billion years.
Yeah, but not like a lot, like whatever, 20 times.
But as humans, barely a fraction of a degree. So.
Yeah.
Well, I say we in the general sense.
Yeah, we, like you.
Planetary we.
You look so young, Nicole, for someone who's been around the galaxy one time. Okay, so let's. Okay, so this is great. Actually, we've got 2 views of the moon, and I think it's important. I want to sort of talk to David now. David, you might be muted. I don't know if you're back.
No, I'm back.
Okay, good. I was getting some feedback. I wasn't sure if it was you, but
that's okay.
But I think what's really kind of cool here is you're focusing sort of a really high-resolution view of the moon here for people, and you're actually focusing on a fairly interesting part of the moon. I'm going to switch back and forth between Roy's view and your view. So Roy's view, and this is the moon right now. Like this is, if you walk outside and you look up, this is the moon that you're going to see, but in a telescope. So where are you pointing right now, David?
I'm aimed very roughly on the edge of the Sea of Tranquility, and right down, I know at the upper left there's a figure-8 looking pair of craters, the Sabine Crater Complex, and I know just down below that, in that blank area down to the left, is the Apollo 11 landing site.
So I think this is good. So I think tonight what we're going to do is we're going to teach people to find the Apollo 11 landing site. And I'm going to sort of switch back to Roy's view, although is it just me, or is the moon backwards in
It's
Roy's
probably
view?
flipped, just the way my camera's oriented.
It's magenta, and I'm kind of digging the magenta.
That's kind of cool.
I love it!
Yeah.
Well, this one is done with my my modified DSLR camera.
Oh, so you removed the IR filter.
Yeah. So I don't have a white balance set on this one in this software, so it comes out with that magenta.
It's a beautiful view. Now, can you zoom in at all?
Not really with this software.
Okay, all right. Because usually with I'm not sure what software you're using, but you can kind of switch.
Yeah,
back
this
and
one
forth.
is just I'm taking 1/100th of a second images, and the other one I usually do live video.
Right, and I don't want to. Well, I guess if it is reversed, because it definitely looks reversed to me. I don't know, Thad, are you?
No, that would be correct. If you're in If you're in the west and you're seeing it rise, this is
No,
about...
there's a window.
Well,
it
actually,
looks
wait,
correct.
no, it's first quarter, so it wouldn't be rising. That's true. It would be starting at sunset, about as high as it's going to get in the sky, looking that way. So yeah, it's rotated maybe about 90 degrees.
Yeah, I can't see out the window.
Yeah.
90 degrees clockwise or counterclockwise?
Counterclockwise. Counterclockwise.
Okay.
Yeah.
I can fix it.
You can fix this?
The first time I was in the southern hemisphere, I was a bit confused, seeing what looked like a first quarter moon in the middle of the day. and you have to be kind of an astronomy geek to actually look at that and go, "Huh, that's wrong."
It's strange seeing familiar constellations upside down from that.
Yes.
Right,
Orion
upside
diving
down.
into the ocean.
Very disoriented.
Yeah.
Desert.
All right, well, I'll switch that around. So, David, there was actually a crater complex that was there. Have you moved your position now, David?
Just a little bit. We're still the Sea of Tranquility is still at the bottom of the frame there. I always focus in, like I said, on those figure-8 craters. That's right off to the left of center. There is a series of 3 craters that are too small to get at this resolution that are actually named after the Apollo 11 astronauts. I did a blog post on them recently. They're about 10 kilometers in size. So they're kind of difficult to see, especially when the seeing is this bad. But there is a string of 3 craters right across the area down to the left of center there that are actually named after the 3 Apollo 11 astronauts.
Now I'm going to move back to Stuart because Stuart's got a new object happening here. I see some kind of star cluster. What's that, Stuart?
This is M56. I'm just on a hunt for star clusters we haven't seen before.
Okay.
I think it's another globular cluster, or globular cluster, as Fraser would say.
Yeah.
But
Green.
well, the color is because I have I've got a light pollution filter, and it's a modified camera, so I don't think it's really this color. It just I don't have the white.
Yeah, because that would be unusual for
Yes.
stars.
Yeah, no, they don't come in green. Well, stars in general don't come in green.
No.
And especially globular clusters where it's all older, redder stars.
red.
So.
You've got M92 up in that area too.
I was just wondering, there's like a little blurry spot in the upper left-hand corner there.
Oh, it wouldn't be in the same frame, but M56
Oh,
is in,
okay.
yeah, M56 is in Lyra. So, just west of where the Milky Way runs through the summer triangle, and then M92 would be a little bit further off to the northwest from there, and of course M13 in that general vicinity also. So, all these ones.
Go ahead.
I was just saying all these ones that Harlow Shapley hunted down back in the 1910s from here in Mount Wilson in LA and said, "Hey, the sun's not the center of the galaxy." So.
One of the neat things about this is it's one of the ones that's moving in retrograde motion, which means it's moving in the opposite direction that you'd expect compared to everything else. Looking at the average motions across our galaxy, there's actually this entire population of globular clusters that have a slightly different composition and are all moving in a backwards retrograde orbit that appeared to be from when our galaxy ate another smaller galaxy and just consumed and virialized the globular clusters that came in with it. Some people actually think that the remnant of that galaxy might be Omega Cen, but it's still being debated in the literature.
This is great. So David is panning back and forth on the moon right now in this really high... Your seeing is kind of improved, David.
Yeah, a little bit. It's a little cooler here than it's been for most of the summer. The moon is down at a very southern declination now, so we're starting to get down into some turbulence over the houses and stuff as everything's cooling off here. But I moved up on the Terminator a little more so you can see where the sun is just starting that 2-week rise there.
Did Stuart move to something else?
It's clearing up, and I've got clouds coming in.
Oh no!
I may move to I see Jupiter over here coming up. I may move in about 10 minutes or so.
Oh, that would be fantastic. Yeah, absolutely. As soon as you think you can get Jupiter, then by all means go after it. Jupiter.
If you see it go black, I'm hunting.
Yeah,
So Pamela,
Roy is totally losing the moon. Go ahead. What were you saying, Pat?
Oh, sorry. Just wondering. So Omega Centauri is another one of these retrograde moving globulars?
And it's a weird one because it has multiple epochs of star formation and its structure isn't normal. So it's actually a dwarf galaxy, not so much as a globular cluster. And so you have this weird little system. Sorry, I'm screwing up my systems. Yes, Omega Centauri is a globular cluster, but there are a few weird papers out there that are claiming that because it has this weird composition compared to all the other globular clusters, that maybe it's closer to being a dwarf galaxy, maybe it's a transition object, but it's in the literature that maybe this is related to the nucleus of whatever was left behind by the galaxy we consumed when we got all of these retrograde globulars.
There are a few. I just wanted to say there are a few arguments in professional astronomy journals that are more intense than the some of the galactic cannibalism debates.
Right.
It's so hard to tell from. You have these populations of stars, and doing stellar populations is a cut and dry thing. And so there's a lot of noise in the system.
Well, and the confusing thing is globular clusters in general are the oldest systems of stars in any of our galaxy's clusters. And so when you look at these globular clusters, you're looking at 13 billion.
I'm listening to the game. It was like 6-1 or something like that.
You're interrupting our science and your sports.
I just muted Stuart.
Okay.
If anyone is watching the game right now, as opposed to broadcasting with their telescope.
Sports team.
Sorry about that. I
Go
thought I was
sports.
muted. It's my daughter.
Go sports.
All good.
Well, you know what, Stuart? As your price of admission here, what have you got in your telescope?
This is Epsilon Lyra, and this is one of my favorite objects in the sky. Actually, it's a double-double, and if you're to look at this under low magnification, you would just see a double star, but if you look at it under high magnification, that double star will resolve into two doubles, and that's what we're seeing here.
Which are the two doubles then? I can see that really bright star in the middle there. Is the other one that one down to the left a bit?
Yeah, to the left. So there's a double, the real bright one in the middle, and then there's a little one above that, and then to the left you'll see another double that's about probably pointed 10, 15 degrees to the right.
Yeah.
And these are true binaries. So this is a quad system where you have two stars orbiting two stars, and my hands don't have enough freedom of movement to do the whole system.
And so I mean it must happen more quickly. How can they tell?
Sorry, I'm enjoying watching Nicole lose it.
I'm losing Skype now.
Do you want to share with the class, Nicole?
Nope. Let's just say Scott Lewis couldn't make it tonight because he's too sick, but he's not too sick to send me jokes over Skype. Inappropriate jokes over Skype.
David, are you moving to going to try and get your camera now? Okay.
Slight problem. The eyepiece holder came off the camera when I went to move it, so I may have to do a repair job on it. So, yeah, we'll see if some duct tape might be able to hold it together.
but regardless,
for kludging.
Yeah, we've
Epsilon Lyrae, we can watch the suckers move. That's how we know.
Oh, we can actually see the move. Okay.
Yeah.
I will be right back.
Okay.
All right, I'm going to move back
Magenta
to
moon.
Roy.
Magenta moon.
Now it looks upside down.
Purple moon.
Yes.
Yeah, now
Oh,
it's
you're
like in the
kidding.
southern hemisphere.
You're 180 off now.
I went
Or
the
in
wrong
the
way.
southern hemisphere. We're good with calling it the southern hemisphere.
Yeah.
Finally, our Australian viewers will get the moon they're familiar
Feel
with.
at home. Our South Africa viewers.
It's kind of unsettling to see the moon like that.
Yeah, that's why I totally freaked out.
Yeah. That's not right.
Well, if you look through a Newtonian, reflector that's without any kind of diagonal on it, that's the view you're going to get. Of course, I don't know why anybody would put a diagonal on a Newtonian reflector, but anyway.
Because
astronomy humor.
Short people.
Yeah, exactly. So, but do we want to do a tour of the moon? Like point at various things and give names?
Yeah. Well, if Roy, you don't have the ability to. So, do you have the ability to flip at 180?
Yeah, I can flip at 180.
Yeah. Just rotate it again. One more time, and then we'll be okay.
We shall flip horizontally and flip vertically.
I love the idea of just flipping the moon around.
Just flip it.
No
It's
big
fine.
deal. It's moment of inertia doesn't make it too hard to move.
So someone mentioned that in Brazil they also have the moon in that orientation.
There you go.
So yeah, you notice I didn't say upside down. Not upside
There
down.
you go. That's very...
No northern hemisphere centricism.
No,
Right.
no. But if there are any southern hemisphere roids watching, who would like to join us, we would be glad to have some people from the southern hemisphere join us and view the telescope. Actually, someone from Argentina volunteered at some point. So
Way to piss off half the planet, Fraser. Fraser!
Well,
what do you mean?
population-wise, it's only 1/5 of the planet, but still.
We'd be in northern hemispheroids. Spheronians?
God.
Sphericans?
Sphericans? Spherites?
Spherites.
I like the idea of hemisphites.
Hemisphites?
Hey, look, it's M27.
Hey!
We've achieved planetary nebula.
Oh, wow.
That's cool.
That's a really good
Is this
view.
using the narrowband filters again?
No, this was just my modified DSLR.
Okay.
This is mine. I assume you're looking at
Gotcha.
mine. I don't know if you're looking at...
Yeah, sorry.
yeah,
I
yeah.
got my windows confused.
No, that's all right.
Got a request for the Saturn Nebula, the Blue Snowball, or the Turtle Planetary Nebula.
Blue Snowball is...
a microphone.
It's really small.
Blue Snowball is going to be too small to see. It's it's really, really small. And I'm just going to be showing the backlog of my images because I've just clouded out. I don't have anything.
Oh no.
Oh, no.
But that's all right.
yeah.
I've got about 5 or 6 more.
Well, this might be the shortest virtual star party ever because we've got, I think, Roy's getting clouded out.
Yep.
David's telescope is coming apart. His eyepiece and Stuart is getting clouded up by that West Coast storm. So,
But
think
I
we'll...
still have some more images to show. I'm trying to find the good one of the comment that I just took. So.
Oh, let's look at some photographs. Example of photograph that Gary has taken.
Yay!
Gary
Yay.
saves the day yet again.
Gary saves the day again. Which one's this, Gary?
That's a bubble nebula.
Yeah.
Wow.
And this is right here is my full field of view. And then I zoom in and see it like that. I just figured I'd throw some of them up.
Yeah, no, by all means. So what's going on here with that picture? With that object? Anyone? Anyone? Is there anyone with a PhD here?
Sorry,
Might know
I
what
was
this is.
distracted by the weather.
I was distracted
Bueller?
by the pretty.
I have no
Dad,
excuse.
this is all you.
So,
Is it a supernova?
I mean, this is... No, I don't think this
No,
is
this
a
is a star
supernova. This
forming.
is... Right, and as the star forms, as it starts giving off visible light radiation, it kind of clears out the area around it and kind of carves out this spherical region in the surrounding gas and dust that it formed from. So what you're seeing is mostly hydrogen gas that's lit up by the radiation from that star that formed in the center of it there.
Now, someone mentioned that it looks like an evil green pig on YouTube.
Do we have an angry bird nebula we could fire at it?
Yes, we do.
Do
I
we
don't
really?
have a picture, but there was totally an Angry Bird nebula.
I wonder if there's
those,
those, like the Pacman Nebula. Like, what did they call the Pacman Nebula before Pac-Man?
Yeah, that's disturbing. I wonder
Right?
though if it's so small that it just hadn't been discovered before the 80s.
Or they just hadn't decided it looked like Pac-Man. I'm just saying, I'm wondering if there are nebulae that we see now who, that we haven't figured out what they look like because the thing that it looks like hasn't been invented yet.
Yeah, no, that's entirely true.
It was the before Pacman Nebula.
Well, I'm going to go back to the dumbbell here.
Future-looking pareidolia.
And I'm just sharing the weather for those of you who haven't noticed the fact that it
Wow.
looks like someone's trying to erase the northeast quadrant of the North Americas.
So you can see over on the left-hand side, you can see the like the west coast. This is all us, so I'm sort of at the top of that right there, where the 17 is, and then all the way down through Oregon and Gary. You can see that all down the left-hand side, and then over on the right-hand side of the country, where a lot of our other astronomers are, you can see the green there. So again, they're all clouded out too. Amazingly, David, down in Florida, you're fine. You wouldn't want to be out in the Atlantic Ocean right now. That would really be awesome.
Yeah, that's profound out there.
Usually the reverse is true for Florida.
Yeah.
Okay, so Stuart, is this a comet?
Yeah, this is Comet Hergenrother. It's a little noisy. Is it really noisy for you guys?
It's not too bad. I can
you can see it. I had to pull it out a little bit using Photoshop with levels because it was so dim. So that's why it's kind of noisy like this, and it was just a real quick pull out. But you can see the what's the nucleus and then the tail.
And what's neat is, if I'm understanding what I'm seeing correctly, you have sometimes you end up with tails that are slightly different, and they split. And this looks like it's one of the ones that has the tail that's being created by the radiation pressure, and then you also have the ion tail.
Now, I'm just gonna plop in my original image so you can see the difference and why I had to bring it out. So you can see it there. So it's really kind of dim right there in the middle. Can you see it?
Yep.
Yep.
And so
this is when your students say, "Is that it?"
Yeah, that's it. That's right.
Now, is it expected to brighten up at all?
It hit perihelion recently, and it wasn't even supposed to be as bright as it is. I mean, there was an outburst on it. I'm not sure if they've determined the nature of that outburst yet. So, was it just a simple temper tantrum, or was it more of a fashion meltdown? No, wrong kind of outburst. Sorry, but yeah, it wasn't even supposed to be as bright as it is. So anything that's happened since then, it's fading out. This thing doesn't even get any closer, really, than the orbit of Mars. So it doesn't come into the inner part of the solar system very well, where the sun's heat can start to drive gases and ices from it en masse, so that the thing brightens greatly. So we got lucky to see this at all, really.
Speaking of things that we just got lucky to see, here's Jupiter.
Yay, Jupiter!
Duct tape to the rescue.
Jupiter to the rescue.
I see no moons.
So duct tape did work.
Yes, I'll show you at the end of the show. I have 3 pieces of duct tape holding the camera onto the eyepiece holder now.
Yeah.
Nice.
So Phoenix Down just mentioned that the Pacman Nebula, NGC 281, was discovered 97 years before Pac-Man was released, and I have no idea why I felt the need to look that up, but I thought I'd share. So
that's awesome. Thank you.
That's awesome. Thank you very much for looking that up.
So I see cloud bands, and I don't see any moons.
Yeah.
Well, usually you got to change the brightness to see the moons.
Okay.
Yeah, I can. There's no moons transiting. I checked earlier, and
they're all lined up.
So they're out of field.
Yeah, the Great Red Spot is also turned away from us right now, so we're not going to see that either. I checked earlier today. But.
Oh man, just some equatorial bands. Oh.
Hey, maybe we'll see an impact.
Boring.
We'll get lucky.
Yeah.
That's funny. Yeah. So it's Jupiter by Jove.
Wow.
That was bad.
Not my joke.
You can tell he's a dad. Only dads pun like that.
Blame the person on YouTube, not me.
Wow.
This is cool.
Who is it? Blake Smith?
One of the cool things about Stellarium is it lets you even see to a level of detail that you can actually see where the position of the moons are around Jupiter.
Yeah.
So this is great.
Fraser, I know this is cheating. I put up a picture of the comet that I did a couple nights ago, just so people can see what it kind of really looks like with a decent picture. And so this is a 15-minute stack of the comet.
Wow.
And I like it. You can see the tail.
Very nice. Very nice.
So it is one single tail. This one doesn't have the multiple tails visible.
Yeah, you can really see it.
Yeah, I thought that kind of phenomena only happened in like closer than 1 AU typically.
I'm not sure. I've imaged them, but it's always been his favors.
David has been able to pull up the moons there.
I see two. I'm not sure which
Yeah.
one is at the bottom there.
Well, if you look in Nicole showing stellarium, that's Io and Europa. So here's the
Awesome.
simulation, and you can see Io and Europa just to the side of it, and then we'll go back to the live view, and you can see those two moons down at the bottom of the picture right now.
I haven't checked with newer versions of Stellarium, but one thing I've noticed with like versions prior to 0.11 is that there'd be some lag between the positions of the moon shown in Stellarium and what it actually is in the sky. Skyviewcafe.com, though, has always been almost dead on for times of transits and eclipses, and that if I'm going to go plan an observing session based on that, I'll go with skyviewcafe.com.
Cool.
Okay.
Good to know.
Starry Night's that way too. With Great Red Spot transits, there's a bit of a lag because when we had that major impact, I was trying to correlate a few weeks ago where that was versus the Great Red Spot, and I noticed Starry Night was a little bit off too.
That's really cool. Do you want to try and see if you can find those other moons, David?
Yeah, let me pan now. Let me look at her map.
Because you got the brightness okay, so I think they're going to be on the other side, right?
Yeah.
Yeah, that's fantastic. And there's a bunch of other objects here, so why don't we... Okay, so here's Gary's photo of the Pacman Nebula.
Yep, since we mentioned, I thought I'd bring it up.
That's nom, 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 nom. Nom, nom, nom. You can see the eye and...
Yeah, before Stuart suggested, I just figured out another thing I need to do in my display program. Add rotate buttons.
Right, you'd want to rotate this sort of clockwise one time, right?
Yeah.
To get the proper nomming.
Well, another piece to add.
Well, you can almost see the stars make perfect little yellow balls for him to eat.
I'm glad I'm screen sharing because I'm making Pacman faces.
Oh man, look at this! And this is the image that we used for this week's Star Party, Stuart, which is the Ring Nebula.
Oh, cool. Well, this I took tonight, so
yeah,
it hasn't. It's the same thing, I think. But yeah, I like this because you can see the color in it, and it's nice and bright.
Are there many? Like I know the dumbbell looked that way too. I mean, is there a?
It's planetary nebula. They're just like that.
They're all going to get this beautiful green color in them?
Well, it's oxygen. So what you're seeing is all of the happily de-exciting electrons in the oxygen.
They go, oh, and then they go up.
Someone asked for Uranus or Neptune. They're pretty tough. Mm. But they are in the sky right now, but they're pretty tough.
And it occurred to me, not that anybody has the kind of sky that we can look for tonight, but because people keep requesting planetaries that are too tiny to see, the helix is in Aquarius, if I remember correctly. Is that is that right?
Yeah,
that sounds right.
Okay, so maybe one of these later virtual star parties, I guess not next week because it'll be full moon, but maybe like one after that, the helix might be a possibility.
Oh, stupid moon. Moon!
Bring on the Uranus jokes.
Uranus would look right about like Ganymede I have here in the center right now, which is not much.
Yeah, so there's we had Uranus and Neptune in one star party. You're going to have to kind of look back through the archive a bit when we saw them. So we've also had Pluto. Mike Phillips is our go-to guy for that. So
planets.
Yeah, for the dim planets and stuff.
Oh wow.
What?
Roy is showing off.
Yeah, I figured since I was getting clouded out, I'd just bring up a picture.
Wow.
What? Pretty.
What is that? I'm going to guess it's IC1805.
It's a star-forming region of some sort.
That's a butterfly.
That's the Heart Nebula,
but it's
isn't it?
the Heart Nebula.
Ah.
You can see all the dark molecular cloud columns at the top.
And that one kind of across the center, yeah.
Yeah.
Sterling just asked on YouTube, does the Ghost Nebula pursue the Pacman Nebula? Is there a Ghost Nebula?
Only until it eats the funky thing and then they reverse directions.
And the heart stays out of it.
Wow, that is beautiful.
Yeah, that's a nice image. That's a really nice photograph. Oh, I got the Hubble Space Telescope photograph here.
It only took me about 16 hours worth of images for that.
Oh, that's crazy.
So worth it.
And I'm not done.
So what's this? This looks like Andromeda, Stuart.
Mine?
Well, both of you, actually, Gary and Stuart.
I've got the Sculptor Galaxy.
Yeah,
do you?
Yeah, it's nothing.
Yeah, that's NGC 253 for Gary.
Stuart, is it? What have you got there?
Yeah, that's Andromeda. That's just a 2-minute unprocessed exposure, so you can maybe kind of see the dust lanes a little bit, but I'd have to really pull it out. And I tried doing it; it just got way too noisy for the small screen.
So I had my students out at I won't say dark sky site, but much darker than 2 or 3 miles north of the Cerritos Auto Mall. Let's see. So they were seeing Andromeda through our 8-inch Dobbs, and this is pretty much the view that you get through an 8-inch telescope. This is pretty much what it looks like. So,
yeah, and I'm not sure if people can see it coming through. You can see the darker dust lanes sort of above the nucleus there.
Mm-hmm.
But then look at Gary's. How long did that exposure take, Gary?
That was under dark skies, and it's about 30 minutes in each channel, red, green, and blue.
Oh, so you actually packed up the telescope and you moved it someplace dark.
Right. This is about a year ago. Anything I put up, I'm trying to find things that are in the sky right now, and this is in the sky.
How often do you do these kinds of trips to dark skies?
I was doing once a year, but I'm not going to do many anymore.
Yeah.
It's too much drain on the body.
Yeah, it's a pretty big telescope, and it takes you a while to get it all going.
But there's some places we went to, Rice Canyon, and that was great when they had the big star party up there.
The Jupiter is clearing up, David. Oh yeah, go ahead, Gary. So sorry, you were saying?
I was going to say this is true color.
Yeah.
This is, if you could see it, is the way you would see it.
Well, Jupiter's getting higher here right now, and I took the exposure down so you can't see the moons anymore, but the disk of Jupiter shows more detail.
Yeah,
it's usually one or the other.
The disk is looking really nice. Yeah.
You get a nice split in the one equatorial band too.
Mm-hmm. Yeah, I believe it was the southern equatorial belt we lost for a time a few years ago. It periodically likes to disappear and come back, and it's been pretty stable the last year or so.
And I mean, for anyone who's watching this and wondering if they want to get into astronomy, I mean, again, this is live video of Jupiter, and so if you have even a smallish telescope, this is kind of what you're going to see through your telescope. You're going to see these bands, you're going to see those moons, and in fact, the eyeball actually has a much better range of light that it can detect, and so you'll actually see both the planet and the moons both at the same time, which look really great. And I actually find even with the smaller telescopes, then you really see the positions of the moons quite nicely. So there's something to be said for both bigger telescopes where you can see the bands on the planet, but also the smaller telescopes where you really see the whole system. Makes you feel like Galileo. You just imagine what Galileo saw when he first looked through his telescope and saw this.
I do image stacking with this rig too, and I get pretty good detail on the disk. Just with Registax and K3 CCD tools for camera control.
And this is you in your sort of with your atmosphere down in Florida, which is pretty.
Oh yeah, there's not many major observatories down here for pretty good reason because East Coast skies are usually pretty chronically bad.
Yeah, I remember we were at Dragon Con and they have that star party every year in Atlanta, right? And they have this out at the university they have this observatory, and it's just. I don't know, like, why bother? It's just the skies were just so soupy. It's pretty rough.
I think we had a hurricane this year.
Yes, you did.
That's right.
I think that's why.
Yeah, we had to provide a virtual star party for the star party, which was fun.
Plus, you have to get a whole bunch of inebriated people to look through an eyepiece. That's just a whole nother issue.
Yeah.
Well, we have really good skies here. It's always cloudy. Just always cloudy.
Slew.
Somebody's slewing.
That's real.
Sorry, that was me.
That's how you know it's real.
Yeah.
Are you still clouded out, Stuart? Or are you?
No, I've got another. It cleared up, so I'm going to try something else. I'm going to try the owl cluster, which we haven't done. What I have up now is M29. This is I did a little earlier tonight. I think it's an open cluster. At least it looks like one.
Yeah, it's an open cluster. It's less than a degree southeast of Satyr, Gamma Cygni. So it's part of that complex that's near the Crescent Nebula. The Veil Nebula is kind of southeast of this. There's the Butterfly Nebula right next to Satyr, just a little bit north of this. This was part of my summer project for this past year, was imaging the portion of the sky around here. So, yep, very familiar.
Somebody said they heard a blender. Maybe we're making margaritas. Yeah.
No, if only.
Yeah, it's my mount.
That was a telescope moving to a new target. Which is
Margaritas sound good, though.
Across as much of the country as we're spread across anyway. It's like, everybody run your blender now. No, it's...
Okay, so now I think we can find the Apollo 11 landing site. So let's take a crack at this, because I can see it right now. So I've switched back to Roy's beautiful view of the moon here. What a phenomenal pink moon.
Magenta.
A magenta moon.
No, purple.
All right, so the large circular patch that's not quite at the far right edge of the picture there, just a little bit above the center, that's Mare Crisium. If you come due, well, let's not do cardinal directions. Let's do just straight left from there. The patch that's directly to the left of Mare Crisium is Mare Tranquillitatis. That bright crater that's in between Mare Crisium and Mare Tranquillitatis is called Proclus, just in case you're wondering. And yes, my students did have to do moon maps within the past 2 weeks, so this is all fresh in my head right now. Let's see. So, if you look along the bottom edge of Mare Tranquillitatis, it's kind of ragged. There's a little bit of a point sticking up from that bottom edge of that Maria. There's a little bit of a white, a little bit brighter crater to the left edge of that point. So if you're out there, I hope you're still following along out there.
There will be a quiz.
There will be. The Apollo landing sites are just above where that white spot is. The Apollo 11 landing site, sorry. The Apollo 11 landing site. Not all of them, just Apollo 11.
And like right now, the way the moon is configured, actually, it's almost like the exact middle point of this visible part that's there right now. I mean, if you sort of, split it halfway top to bottom, split it left to right, there's almost like a bright white spot, the very center dot of the area of the moon that you can see right now. And that's where it is. Oh, can you move? Actually, yeah, Roy, can you move up a little bit? Move up? I don't know if you can. A little more? A little more? Right there.
All right.
Yeah, so that is the Apollo 11 landing site.
It's just a little bit above that.
And you'll never forget this now, because you just look for that bright white spot on the moon. What's that crater that's just to the lower to the left there? The one with the central peak in it.
Oh.
Oh, okay.
Yeah, that's, major features come to me, but what is that one? No, it's not coming to me off the top of my head. I mean, I know we're looking at like Fumarius and with the rays down below that he was pointing at before he had moved up to where the Apollo 11 landing site is. But nope, I fail on this one.
Oh, okay.
All right. Come grab my PhD off the wall. Take it away.
You're still doing better than I've ever done.
Yeah, I think we'll do a moon. I guess 2 of them, right? I guess we should do one when it's waxing, another time when it's waning, right? And we'll get to. Well, there we go.
Wax on.
There we go. So there's a view of all of there's the Apollo 11 landing site.
Yay.
I did this for a blog post a few weeks ago. You can see where actually the 3 craters that are named for the Apollo 11 astronauts. And Surveyor 5 and Ranger 9, I believe Ranger 9 impacted that area up to the north. I don't think it landed. No, none of the Rangers landed.
That's landing.
Yeah.
Yeah.
It's a form of landing.
Buzz Lightyear would call it landing.
That's true.
Let's go back to Stuart's new cluster here. Oh, that's a nice one.
Yeah, this is the owl cluster. I'll leave it to Thad and people to tell me what it is because I'm working on something else. But I think it's it looks like an open cluster to me.
Yeah, it's an open cluster. Do we have a pussycat cluster too? No, I guess not. But yeah, open cluster. So we had a bunch of stars roughly forming at the same time from a dark molecular cloud of gas, and so that's the thing with any cluster. You're looking at stars that are all roughly about the same age, though they may not be about the same size. But if you can see when stars are starting to evolve off the main sequence, so when they're going from main sequence stars to red giant or red supergiant stars, you can get an idea for the age for the thing. I have no idea what the age is for this one, but just some information if you wanted to
you can see the HR diagram with your eyes.
2.2 billion years. No, okay.
Put on my color magnitude filters.
2.2 billion years.
No, I don't. I have no idea. Making stuff up. Making stuff up.
It wouldn't surprise me.
And if you're still on me, I have another cluster here ready if you want to see it.
Sure. Go ahead. Hit us.
Go for it.
This is also in the Cassiopeia region. This is NGC 663. And they say that this should have made Messier's list.
Yeah, there's a number of things that it's like, Messier, how did you miss this?
Yeah.
You know?
Well, but his list was distinctly things that he saw that he kept mistaking for comets. So he may have looked at that and gone, yeah, that's clearly not a comet.
But the Pleiades are on there. Why
I know. He's inconsistent.
Yeah.
Yeah, a little
Did you
bit.
find any comets?
Yes.
Okay. It would be really funny if you like.
We did a whole show on it.
Okay.
But the thing that's quite funny is there's lots. I mean, he was observing from France, right? And so he's only seeing objects in the northern hemisphere. And so there's a whole pile of objects that would absolutely classify, but they're all in the southern hemisphere. And
Right.
so
Sir Patrick
very
Moore
good
made up the
hemisphere
Caldwell catalog using his mother's maiden name.
right. And so now you've got a larger list.
Yeah.
Well, we're starting to get sort of closing in on the hour, so we'll sort of take a few last looks at some objects, and then I think we can probably wrap it up before that storm takes off the whole west coast.
Kills everyone.
Jupiter's looking better.
I got a picture.
Yeah.
That Jupiter is improving. You can.
Yeah, very
so
nice.
I think this is really important. If people have been watching sort of Jupiter from the beginning and to now, the view is really improving.
Yeah.
It's about 30 degrees above the horizon here right now, so yeah, it's
That
definitely
helps.
it's getting into better. I may do some imaging after we get offline here.
So, a couple of things. One, a few people are telling us that crater with the peak in it is Theophilus. Is that right?
Theophilus.
That sounds right. That sounds right.
Yeah, so that's Theophilus, is that crater with the central peak.
Thank you, viewers. Thank you.
And then Tom Nath is mentioning that Messier found something like 15 comets from downtown Paris.
One thing I remember from living in Florida is that from November through March, it tended to be pretty nice as far as
we're just getting
goes,
into the good astronomy season down here when it actually is clear and cold at night. So.
Isn't it also the good hurricane season though?
No,
that's ending.
Oh, you're ending, right? Your hurricane season.
Just getting toward the end. Once in a while, if a hurricane can sweep through, it can you get some really nice clear days right behind that.
Yeah.
And if it knocks out the power, then there's no light pollution. So.
That's true.
Or you can do real quick and be in the eye of the hurricane.
For about
Best
really
sucker
hard to
hole
pull
ever.
a line.
I know people during Hurricane Andrew said that they could see like the Milky Way right from downtown Miami because the power was out for like several days.
Right. As all their houses were destroyed and the lights weren't working.
Yeah, and they were going, "What's all that?"
Yeah. Like the calls from New York when there was a blackout in New York City, and there was like, I see smoke rising from the south. What's going on? Is there? And no, you've never seen the Milky Way before.
Yeah, I remember that.
That's
I was living in
sad.
New York at the time. Yeah.
I would love
My
to.
neighborhood knew what it was.
If there's somebody like on
Go,
YouTube
Nicole.
or something, if you've never seen, I'd love to see someone post. If you've never seen the Milky Way, that would be interesting. So, yeah.
I have a picture of the Milky Way.
I can see the Milky Way from my backyard. So.
Yeah. We can see it here, Nicole.
Really?
Yep.
Yeah, you
It's
probably
not
have the
on my
same
blog.
view. It's
Not
you
on
got to
my
have a
blog.
nice Gotta have a nice darker night and.
A lot of crappy lighting.
I'll take you out to the barn, and you can encounter my horse whose head is as big as your body, and the Milky Way.
In the dark. In the dark. That's a great idea.
Yeah. Scary horses in the dark. Cool. Well, why don't we sort of wrap things up now?
I have a picture of the Milky Way.
Oh, let's see this picture of the Milky Way, because all I'm seeing.
It's in radio.
Oh, great! Oh. A radio view
of the Milky Way. This is the sky from the southern hemisphere at 150 megahertz, and that line down there is the Milky Way.
That's awesome.
That's
wow.
This is my only good astronomy picture, and that's Centaurus A. So yeah.
Okay.
It totally is when.
Yeah, that's Sen-A. It lobes and a bunch of point sources and some really not so great calibration, because this was right after we deployed a whole bunch of antennas in the desert in South Africa.
All right. Well, why don't we wrap things up then? So, not that that's not fascinating.
It is.
Your radio view. No, it's great. You should hook up a radio telescope in live though sometime.
We want
to. I totally want to.
How would that work?
If somebody has
cool.
If somebody
Actually,
has
that could be any time of day too.
Yeah, I know.
Radio telescope, you don't need a dark sky, so.
Well, millimeter, you need good weather.
Yeah.
Yeah, you need the mountains in Chile.
Okay, well then.
If you wish to send me the equipment, I will put it at my observatory.
Sweet.
Cool. Okay, so let me just think. Is there anything to mention? So we're going to do this again next week on Sunday evening. The next thing that's going to happen is I believe we're going to be recording Astronomy Cast tomorrow. Yep. We missed last week, so we've got an episode to record this week. Yeah. Uh-oh. All right. Oh, I like that loud. That was very loud. Okay, well, why don't we say goodbye to everybody? So thank you. That's awesome. Thank you very much, David. That's fantastic work with your duct tape.
That's the duct tape right there. Yeah, it's it repairs lunar rovers and also webcams. So.
Yeah, no, you did a fantastic job. That was
cars.
Nice.
You ever saw my old car?
Is my last image, Fraser. There's M33.
Nice. Wow.
That's stunning.
Yeah.
Oh, that's beautiful. How long did you do that for?
That was 3 minutes.
Okay. Oh, that's a nice image. All right. Well, thank you very much, Roy. Well, I'm gonna mute you, David. Thank you very much, Roy. Thank you, David. Thank you, Stuart. There's Stuart's another cluster. And thank you to Gary and Nicole and Pamela and Thad. It was great to have you guys all join us. Thanks to everybody watching, and we will see you all next week.
Bye-bye.
Goodbye.